So moment of inertia depends on the location of the body. It depends on the way the mass of the body is distributed, and it also depends on the axis at which it passes through. So the basic formula for moment of inertia is I is equal to m let's say ml square, where m is where this is the moment of inertia, this is mass of the body, is the length of the object. So we have the moment of inertia, it differs in different objects. So when we are considering a rod, the moment of inertia is different from when we are considering a circle, when we are considering a ring, a disc, or a cylinder, or a sphere. So you need to know the moment of inertia of some bodies. Some bodies, you need to know them offhand. There is a way they derive them using integration, but to know them easily for your exam question, you just need to know them offhand. So a rod, for a rod, number one, for a rod, the moment of inertia is I is equal to 1 over 12 ml square. That's for a rod. Can you see the board? Yeah, so for a rod, the moment of inertia is 1 over 12 ml square. That's for a rod, 1 over 12 ml square. What for circle, the moment of inertia is 1 over 2 m r squared, because the r is radius, so the circle is always radius, so is 1 over 2 mr squared. Why for sphere, the moment of inertia is actually 2 over 5 mr squared, because since you are considering a sphere, it has to be in radius, not length. So for cylinder is actually the moment of inertia of cylinder is actually the same thing as that of a circle, because when we are considering cylinder is like this. This is the shape of a cylinder. So when we are considering the axis to be taken like this, cylinder is just like two circles. So since we are considering the axis to be like this is still a circle. So the moment of inertia is still circle 1 over 2 mr square. But when we are considering the axis to come in this way, then this will not be a circle, this will not be like a rod. So the moment of inertia will not be 1 over 12 mr square. But most of the time, we consider the cylinder, we consider the axis to come like this. So this is a cylinder, the way the axis pass through the cylinder, not like this. If it's like this, it's already a rod. But if it's like this, consider it to be a cylinder. So the moment of inertia is still the one of circle, which is 1 over 2 mr square. That of ring, yeah. So the one of ring, you should also know the one of ring. Is just the one of ring is just mr square. As moment of inertia of ring is just mr squared. So moment of inertia of ring is just mr squared. So you should know. There's also that for disc. Moment of inertia of disc is just moment of inertia of circle, because disc is circular. So it's also half mr squared. So it's just fancy ways of putting or representing circle disc. So you should know all this. So there's one moment of inertia you need to know for holosphere. It doesn't come out like that, but it's a good thing to know. So for holosphere, the moment of inertia is I is equal to 2 over 3 mr squared. So I is equal to 2 over 3 mr squared for holosphere. So now we've talked about moment of inertia. Now let's move to the radius of gyration. So the formula linking radius of gyration, first you need to know is radius of gyration is represented by letter K. And the formula linking radius of gyration to moment of inertia is this formula: I is equal to m mk square, where this is moment of inertia, this is your mass, and this is radius of gyration. So when you are asked to find the radius of gyration of a rod, you first find the moment of inertia, then the mass will be given, then you calculate for your radius of gyration. Now let's move to parallel axis theorem. This theorem is just for solving questions when when we are not considering it coming from the axis, from the central axis. So you know, when we say the moment of inertia of a circle, the moment of inertia, we are considering it from the center like this, when it is passing through the central axis. That's why we are considering the moment of inertia to be 1 over 2 mr square, right? But when it is not like, it is not in the center. Okay, let's assume it is here. What if it is here? What if it is here? Now, what is the moment of inertia? We cannot use 1 over 2 mr square because it's not from the center. So that's why we now have the parallel axis theorem, and there's the formula for it. So we use the parallel axis theorem when it is not passing through the center, and there's a formula for it. Sorry. There's a formula for it, and the formula is just the moment of inertia is equal to the moment of inertia when it is passing through the center of gravity. That's when it passes through the central axis, plus mh squared. This h is just the distance from the point we are considering to the central axis. So let's say we have a rod now. This is central axis, and this is the this is what we are solving for. This is central axis, and this is the point we are considering. So the distance from the central axis to the point we are considering is our h. So that's just it. So that's the meaning of h. So we can also apply this to solving questions. There's a question in the slide. Maybe we should solve that so you can understand better. Yeah, and I forgot to say something. You should also know that the h here is perpendicular distance, not just distance. So it has to be perpendicular. It has to be perpendicular. Get. So that's the perpendicular distance. So let's go about solving a question. There's a question. I think I wrote it down. So any question I'm solving in any of my videos, you should know that to get access to those questions, just go to the link below the description of this video. The description of this video, there's a link there. You just press the link. It's a Google Drive link. So when you click on the link, you get access to the videos, to the questions, and that's how I get. So you don't need to like come to my message and say where's the question. If you really watch the video, I always say that to get access to the question, just go to the video description. So let's solve. There's this question. Let's solve this question. I wrote it down. So we come. So the question says, calculate the rotational inertia. That was moment of inertia. Calculate rotational inertia of a meter stick. So now we are considering a meter stick. This is a meter stick. Let's say this is a meter stick with mass 0.56 kilogram. That's our mass. The mass of the stick is 0.56 kilogram. About an axis perpendicular to the stick with mass 0.56 kilogram about an axis perpendicular to the stick and located at the 20 centimeter mark. So the point we are considering is located 20 centimeter mark. So this is the 20 centimeter mark, right? Let's say this is 20 centimeter. Since this is 50, this is 50. This is 50 centimeter. So okay, it is a meter stick. Let's say that's a meter rule. A meter rule is 100 centimeter, 1 meter. So the middle will be 50 centimeter, center of gravity. So the point we are considering is just 20 centimeter. So they are now asking us to find the rotational inertia, and they said we should treat this stick as a thin rod. That means they are already giving us inspo that the moment of inertia we're supposed to use the moment of inertia of a rod. So that to just apply your parallel axis theorem. Since it's not from the middle, it's from 20 centimeter mark. That means what we need to do is apply our parallel axis theorem. So this is the formula here. I is now our moment of inertia in center of gravity. That's the when we are considering from the central axis. For rod, it is 1 over 12 m l squared plus m. Now, what's our h? Our h is the distance between the point we are considering to the distance between the center of gravity. And looking at it, that's 50 minus 20. That's 30 centimeter, right? But our unit has been meter, not centimeter. So to convert from centimeter to meter, I just have to divide by 100. So that's 0.3 meter. That's 0.3 meter and scale it. So let's just fill in our details. That's 1 over 12. Mass is 0.56. 0.56. Our length, the length of the meter is 1 meter, 100 centimeter, which is 1 meter. That's 1 square. Plus the mass here is 0.56 bracket 0.3 square. So let me just solve this directly in my calculator. Yeah, so I've gotten the calculator. So let's just use the calculator to solve this. 5, 6. So this is 0.0467 plus, then we do this one here, that's 0.56 times 0.3, 0.3 squared, 0.56 times 0.3 squared. That's 0.0504. So when we add all these together, plus that's 0.0467 plus 0.0504, we have 0.0971. We have 0.0971. And taking these two, hope you can see the board. Okay, so taking these two standard form, that's 9.71 times 10 raised to power minus 2. Now, what is the unit of inertia? Moment of inertia. The unit of moment of inertia is just kilogram meter square. Kilogram meter square. This is mass. This is length. Meter square mass. Unit of mass is kilogram. Unit of length is meter square. That's kilogram meter square. So that's our unit. Kilogram meter square. So don't play with the units. You might get your value and the units might be in kilogram per meter square, and you pick it. So it's actually kilogram meter square. So this is the answer to the question. Question is on slide, and this is how they got it. So let's move forward.